So ang ating pag-uusapan in this session is all about deflections of beams. So I think matatapos naman natin ang ating mga lessons within this whole period regarding about deflections of beams. So yung ating mga tatalakayin, I think it's all about double integration method ng deflection of beams. We also have the moment diagram by parts. And yung pinakauli, we have the superposition method. And to start with, sisimulan natin sa ating double integration method regarding about deflections of beams. If you have any questions, kahit na nagdi-discuss ako or nako-compute ako, maaari din kayong magtanong. Huwag ninyong ikaya yung pagtatanong. So we have now the beam deflections. Ang ating mga objectives. At the end of the lesson, the students should be able to know the basic concepts underlying beam deflections, mapa-double integration man yan, or gamit ang moment diagram by parts, and mapa-superposition method man ang ating gagamitin na method. And also, determine the deflection of beams, yan, using double integration method. Know the basic concepts underlying moment diagram by parts. Actually, may superposition method pa tayo, hindi ko na lang naisama sa ating mga objectives. And then solve worded problems. So kailangan within the whole period, ma-meet natin ang mga objectives natin. Now, this is how we define double integration method. Actually, double integration method is a powerful tool in solving deflection and slope of a beam at any point because you will be able to get the equation of the elastic curve. Napaka-importante na malaman natin at matutunan natin kung paano hanapan ng actual deflection ang ating dinidesign na structural beam. Kasi dito, pag nakalculate mo ang actual deflection ng beam, may kukumpara mo yan sa allowable deflection ng given beam. Kung ito ba ay nag-exceed or tama lang. Kapag nag-exceed ang actual deflection sa allowable deflection sa span of a beam, ang kapupuntaan nun mga lakis, kailangan nating mag-redesign. Magpapalit tayo ng dimension ng ating beam or ng properties ng ating beam. Kaya built-up shapes yan o rectangular man ang figure ng ating beam. Ang deflection is actually the last step in the design. After na na-check mo ang flexure at ang shear, kasi kapag nag-design ka ng beam, check for shear, kailangan safe. Check for flexure, kailangan safe. Naging safe man sa dalawa, pero nag-fail sa deflection, kailangan mong mag-redesign at magpalit ng dimension kung ikaw ay nasa reinforced concrete. Or kung ikaw man ay nasa reinforced steel design, yung iba naman is timber design. In calculus, the radius of curvature of a curve y is equal to f of x is given by this equation. Rho, yung symbol na to is tinatawag nating rho, is equal to this equation, to this expression. 1 plus dy over dx to the second power, and then nakabracket yung buong yan to the 3 over 2 power all over second derivative. In the derivation of flexure formula, the radius of curvature of a beam is given as rho is equal to EI over M. Okay, E stands for the modulus of elasticity, and then yung I as inertia, and then M as the moment. yung rho, ito yung symbol ng ating radius of curvature. Now, what will happen next starting from this equation? After natin magsimula dito, ano susunod? Deflections of beams is so small, and that's very true. Ito yan. Minsan, hindi mo man mapapansin na may deflection pala. Hindi yan makikita ng basta-basta lang. Such that the slope of the elastic curve dy over dx is very small. And squaring this expression, the value becomes practically negligible. Hence, yan, ang ating formula ng radius of curvature is 1 over second derivative or 1 over y double prime. Thus, EI over M is equal to 1 over y double prime. Intindihin yung mabuti yung mga equations natin. Naintindihan ba kung bakit tayo nag-arrive ng EI over M is equals to 1 over y double prime? Hello class? Naintindihan ba natin kung bakit nag-arrive dyan?
Yes po.
Ito yung dalawa. Oh. Pareho lang namang row yan. So, inequate natin yung dalawang yan. That's why we have this formula. And if we're going to simplify this, we will arrive with just 1. Ito mamimaintain lang sa baba. Kapag in-apply natin ang algebra sa ating numerator, ang value niyan is simply equal to 1. But d square y over dx square is 1 over y double prime. And equating these two equations of rho, ito at saka yun, we will finally arrive with this equation. EI over M is equals to 1 over y double prime. Then coming up next, ganito siya. Okay? Lamnamin yung maigi yung equation. If I will cross multiply y double prime, ito. If I will cross multiply this to EI, aakit yan. At syempre, ito rin yung y double prime natin. And if I will cross multiply M, here sa numerator, M times 1 is equal to M. That is why we have now this formula, EI times the second derivative of y with respect to x is equal to M the moment. Kaya tinawag na double integration, that time na nag-integrate tayo both sides dito sa ating EI times d square y over dx square is equal to M, mag-a-arrive tayo sa equation na yan. Every time na nag-integrate tayo, going back to your indefinite integral calculus, we always add arbitrary constant. For the first integration, we will add c sub 1. So yan ang ating formulation sa ating first integration. Then, for the second integration process, we have EI y is equal to the multiple integral of m dx dx plus c1x plus c2. In double integration class, indefinite integral, kailangan integrate muna natin yung bibilugan ko. Ano man ang integral na lilitaw dyan, doon pa lang natin magagamit ang dalawang yan. Ang integral sign na bago, yung last at saka yung isang dx pang isa. Klaro ba? Klaro? Going back to your multiple integrals. Klaro ba? Yung mga naging integral calculus ngayon, alam ko meron kayong multiple integral na topic. Okay, so let's proceed. Para maging klaro yung discussion natin regarding about double integration, kailangan na meron tayong halimbawang beam na ating hanapan ng deflection. So ito yung ating unang problem, C board exam problem. Determine the maximum deflection in a simply supported beam of length L carrying a concentrated load P at midspan. So ibig sabihin meron tayong concentrated load na P sa pinakagitna ng span ng ating beam. Ang length ng ating beam, I've used the variable L which stands for the length. Ibig sabihin variable yan. Now, yun yung ating figure. Pag-aralan nyo muna maigi ang figure before we proceed. Ang hinahanap natin is actually the maximum deflection. And this is also what do we call the Y max. So, inaanap natin ang value ng ating maximum deflection, which is also actually our actual deflection. Iba kasi ang ginagamit nating formula sa allowable deflection. Now, actually, kapag naganap ka ng Y max, may una tayong mahanap. Ito yung theta max, yung slope. If I'm going to draw the elastic curve, ganyan yan. Okay? So, ito yung inaanap natin, yung ating maximum deflection. Ito naman, ito yung slope ng ating beam, theta max, so the maximum slope. With our first integration process, we can actually determine the slope. But after the first integration process, proceeding to the second integration process, dun pa lamang natin mahanap ang ating maximum deflection. Pero siyempre, kailangan binabalikan natin yung algebra natin, yung kagalingan natin sa algebra, kung paano ba ang pagko-cross multiply, paano ba ang pagsisimplify, pag-aanap ng unknown variables like yung C1. C1 may role dito, no? Malaki ang papel na gagampanan ng ating mga arbitrary constant dito kasi ang ating mga C1 and C2 mamaya pag-aaralan natin kung paano ang pag-aanap ng values ng C1 at ng C sub 2. Pero siyempre, hindi ka naman basta makakapag-double integration. Ikaw din mismo dapat marunong kang mag-formulate ng equation na yung gagamitin sa yung double integration process. Kaya nga pinag-aralan muna natin ang shear and moment diagram para matutunan nyo muna ang pag-aanap ng reaction. After na marunong na kayo ng pag-aanap ng reactions, proceeding to the deflection method, like double integration method, usually, nagkakaroon tayo ng mga cutting sections. In this case, ang cutting section natin, class, are you still with me? Naintindihan ba yung lesson natin? Ito yung ating cutting section, section AA. So, dyan tayo nag-cut. And we have actually already computed for the reactions. And we have P over 2 both sides. Ang ating concentrated load is P. O nga naman ang P. Kalahating P sa left, kalahating P sa right. Kapag tinotal natin ang dalawang P over 2, that is also equals to P. Upward direction. Ang downward direction natin, ang value din lang ng ating concentrated load is P. So, ibig sabihin, equal lang. So, if you will try to check it using summation of forces vertical, the left and the right hand side of the equation that can be formed, mag-i-equal yan both sa 0. Klaro ba? Mga anak, hello? Hello? Are you still with me?
Opo, sir.
And then, tingnan natin. Yan, ito yung length. L over 2, L over 2. Bakit L over 2 pareho yan? Kasi nasa gitna yung ating concentrated load. And it was already mentioned naman sa problem kanina. Now, if we were going to proceed to the solution process, ganito lang kadali yan. Actually, pwede kong dagdagan yung P dyan. Pwede kong gawing 3P, 4P, 5P, 5 concentrated load. Yung proseso, ganun pa rin. Okay, so let's proceed. Okay? Nag-try akong mag-construct ng cutting section at this point before the P value or the P concentrated load natin. Now, in this situation, kailangan muna nating mag-construct ng ating moment equation. As we can see here, meron naman tayong reaction. Ito yung ating reaction. P over 2. And from this point until there, we have a distance of x hanggang doon sa cutting section natin. Now, what do we do next? For our solution, considering the left of AA, the cutting section of AA, so ibig sabihin sa left, ito yung kino-consider nating portion, no? Left of AA, ito. Yan lang. So, moment is equals to P over 2 times X. Why is it P over 2 times X? Saan ba tayo nag-moment? Dito tayo nag-moment sa point na yan. Kung saan yung cutting section natin, yung hangganan. So, ito yung point ng cutting section natin. And it so happened that this is an upward force. Kung doon tayo magmo-moment, ang layo ng P over 2 doon sa point, mag-umpisa sa level na yan, is X. So, meaning to say, this is our perpendicular distance. So, clockwise, ang direction natin, so positive. So, the moment value is now P over 2 times X. So, meron na tayong moment equation, which is actually equal to P over 2 of X. Then, pwede na nating simulan ngayon ang ating double integration process by using our expression EI times the second derivative of y with respect to x is equal to the moment. I-equate natin ang value ng moment natin dito. Yan. In doing that, so magiging ganyan na ngayon ang equation natin. Are you still with me, class? Hello? Hello?
Opo, sir.
So integrate natin. Okay? Yung nasa left, automatic na integrate na, kaya naging ganito siya. Nagdagdag na tayo ng C sub 1, automatic mag-integrate kasi tayo. Shinortcut na lang sa formula. But usually, in practice, dapat ganito muna yan eh. Paliwanag ko, no? Dapat ganito muna yan. Ganyan muna yan. So, kapag in-integrate mo ito, ang output, ito. Kapag in-integrate mo ito, magdadagdag ka ng C sub 1. Dito, na-delay lang ng konti yung integration. So, integrate natin. If I'm going to integrate P over 2 of X, what is then the value? Tingnan ko nga kung naalala pa ninyo ang inyong integral. With respect to X tayo, paano ko ba integrate yan? Anong output natin sa P over 2 of X dx integral? What will be its value? Class, if I'm going to integrate this, what is the value? Anong outcome natin? Anyone? Oliver, nandiyan ka ba, Oliver? Kapag yan ay in-integrate mo, anong magiging value? Do I? Wala yata si Oliver. Anong value niyan kapag in-integrate natin? Look at this. If I'm going to integrate 2x dx, its value is 2x squared over 2 plus c. Tama? Automatic may 1 yun eh. Mag-a-add ka ng 1. Ito yung formula, di ba? Na paano kayo, class? X to the n plus 1 over n plus 1 plus c. So, anong value nito? Tatagal tayo dyan. Anong value niyan? Hello, class? Now, if I'm going to integrate that, okay, never mind. Diretso ko na lang. Px square over 4. Ano ba ang integral ng x dx? Di ba? X square over 2. Di ba? So, magiging px square over 4 kasi 2 times 2 is 4. Now, we already have this. May c sub 1 na tayo. Then, let's proceed. Next step. Since nasa midspan tayo, when x is equal to L over 2, midspan eh. Okay, L over 2, ang value ng ating dy over dx, iset natin sa 0. When x is L over 2, we have to set dy over dx be equal to 0. And then, let us calculate. Then, for this value. Yan ang magiging value ng ating c sub 1. But kung ang x daw is L over 2, it only shows na ganito yan, ano? Kung yun, sinet natin na 0, yung EY at yung dy over dx, so ganito yan. EI. Ano ba ang dy over dx? 0. Equal P over 4. Nakasunod ba kayo, class? Are you still with me? P over 4. Then x square. Ano ba ang x? L over 2. Nakascore yan. Plus c sub 1. Whatever will be the value here, if we're going to transpose it to the left, it will become negative. That's why we have this value. Are you still with me? Naririnig pa ba ang boses ni sir? Do I? Nadidinig ba ninyo ako?
Naririnig pa po.
Okay. So, malinaw ba ang pagkakaanap natin ng c sub 1? Malinaw ba? L square. 2 square is 4. So, 4 times 4 is 16. That's why we have negative PL square all over 16 ang value ng ating c sub 1. So, after na maanap ang c sub 1, ang c sub 1 actually, yan ang value ng ating slope. So, theta max now is equal to negative PL square over 16 EI. Imumultiply lamang natin ng 1 over EI, ano man ang ating maanap na value ng c sub 1. So, naanap na natin ang ating maximum slope, theta max. After maanap ang ating maximum slope and value ng ating C1, proceed to this one. We can now proceed to substitution. Okay, and then the next integration process. Integrate ko uli ito. Okay? And then, integrate ko uli ang C sub 1. Okay, ito, no? Ito, integrate ko yan. Balikan ko, no? Integrate ko uli yan. Kapag in-integrate ko yan, magkakaroon ng dx. Integrate ko uli ito. Pag in-integrate ko yan, magkakaroon din ng dx. So, mag-a-add ako ng c sub 2. Kapag in-integrate ko ang dy over dx, magiging y na lang. That's why we have arrived with this. Okay? So, let's proceed. Substitution muna tayo. Ano ba ang value ng C sub 1? In this case, hindi ko muna sinubstitute. Dineretso ko muna para hindi tayo mahirapan sa calculation. Okay. Ang integral ng x squared dx is x cubed over 3. So let me show you. Ang integral nito is x cubed over 3. But 4 times 3 is 12. And then we have px cubed. Ang integral ng c1 dx is c1x. So naka-add na ang c sub 2. So tapos na yung double integration process natin. Ngayon naman, useful ito, no? Lagi niyong ginagawa yan. When x is 0, y is 0, c sub 2 is also 0. Then coming up next, we do the direct substitution process. From this equation, cancel na ang c sub 2. Eh may value tayo ng c sub 1. I think that is negative PL square over 16. Then by direct substitution, at midspan, y is our deflection or maximum deflection when x is equal to L over 2. Lahat ng x na may meron tayo, dahil ang maximum deflection natin is nasa midspan, papalitan lang natin ng L over 2. Therefore, yan. So, direct substitution. Okay? Proceed. Ang ating EI times deflection is negative PL cube over 48. Dividing the entire equation by EI, this is going to be our maximum deflection. Negative PL cube over 48 EI. The negative sign here only shows that there is a deflection. Kaya may negative symbol ang ating sagot. Naintindihan ba? Klaro ba mga anak? Hello?
Opo, sir.
Ayun. Usually, sa mga problems, ang binigay ko kasi is pagde-derive ng kahit na simply supported na beam na may isang concentrated load sa gitna. Kahit palitan ninyo yung P dyan, palitan ninyo yung length, anuman yung amount ng concentrated load, kung ganyan lagi yung beam, nagbabago lang yung value ng P at ng length, meron na tayong formula ng concentrated load P na simply supported na beam. Yan. Yan ang ating formula sa lahat ng beam na simply supported na may concentrated load na P sa gitna. Ilan man ang amount ng ating P, 100 kN yan, palitan nyo man, ito lang ang formula natin. Okay? Pwede rin ninyong practicein ang pagsasolve ng maximum deflection gamit pa rin ang ating double integration method nang hindi minememorize yung formula. Makikita ninyo, sundan nyo lang yung prosesong yan. Pareho lang yung amount ng deflection na makukuha natin. Kasi nga yun din yung formula kung saan tayo nag-arrive. Ito class, yung example na ibinigay ko sa inyo, as a civil engineering student, magsilbing stock knowledge na sa inyo yan. Ngayong nalaman na ninyo kung paano nahanap yan, very useful yan. Ngayon pa lang sinasabi ko na sa inyo. Kabisaduhin ninyo ang value ng deflection yan at saka ng slope ng simply supported beam natin na may concentrated load P sa gitna. Kumbaga sa mga knowledge na inaaral niyo sa engineering, very, very basic lang yan. Sa board exam, formula lang yan. Kinakabisado nyo lang. Pero abang nasa school kayo, dapat alam ninyo kung paano nag-arrive sa formulang yan. Importanteng marunong tayo ng derivation of formulas. Second problem. Determine the maximum deflection in a simply supported beam of length L carrying a uniformly distributed load of W, Newton per meter applied over its entire length. So, ibig sabihin, ang beam natin, uniformly distributed load yan. Yung uniformly distributed load na beam na yan, class, kapag nagde-design tayo ng mga beams ng given building, very useful yan. Yan ang mga laging nagagamit na estilo ng mga beams. Kapag tayo ay nagde-design ng mga simpleng apartment lang, ng mga bungalow lang, very useful yung mga yan. Kahit na mga high-rise pa, ginagamit lagi